What if your Arduino could tell how far an object is without touching it at all? That is exactly how parking sensors, robots, and obstacle avoiding systems work. In this lesson, we are going to do the same thing using an ultrasonic sensor. This is lesson 16 of our 24-part series called Arduino for Beginners. Today you'll learn how ultrasonic sensors work, how to connect one to your Arduino, and by the end, you'll build a cool project that measures distance and displays it on an LCD. Sounds interesting? So let's get started. As I mentioned earlier, the ultrasonic sensor is a very powerful tool for measuring distance. It works by using sound waves, but not the kind we can hear. Ultrasonic sensors emit sound at a frequency higher than 20 kHz, which is above the human hearing range. If you look closely at the front of your sensor, you'll notice two circular components. One of them is the transmitter and the other is the receiver. The transmitter sends out a short ultrasonic sound wave. That sound travels through the air, hits an object in front of the sensor, and then bounces back, just like an echo. When the reflected sound returns, the receiver detects it. Now here's the key idea. If we know how fast sound travels through air and how long the sound takes to go out and come back, then we can calculate the distance to the object. Sound travels through air at a fairly constant speed, about 343 meters per second at room temperature. We don't need to memorize this value, it's already handled inside the code. What really matters is time. Distance is equal to speed multiplied by time. So if we measure the time it takes for the sound wave to leave the sensor, hit an object and return, we can calculate how far that object is. Think of it like this. The ultrasonic sensor shouts and then listens. The Arduino measures how long it takes to hear the echo. The shorter the time, the closer the object. The longer the time, the farther away it is. To measure that time, we rely on the Arduino's internal clock. The clock starts counting when the ultrasonic pulse is sent, and it stops when the echo is received. Using code, we store the time value in a variable, apply a formula, and convert it into a distance, usually in centimeters. That is all the theory you need to understand what is happening. Now let's move on and build today's project. Before getting our hands dirty, a quick thank you to the sponsor of this video, Jeff Robot. Jeff Robot is one of the top global providers of hardware for makers, students, and engineers. They offer a wide range of high-quality components, sensors, and development ports. And the best part is that they deliver worldwide. As part of this Arduino series, they sent me the Mind Plus Arduino coding kit, which is a great set of components for beginners. The kit includes an Arduino Uno, multiple sensors and modules, jump wires, an LCD screen, and everything you need to follow along with the projects in this course. I genuinely recommend this kit if you want to build the same project I show in these lessons and learn faster by practicing. Thank you again to DF Robot for sponsoring this content and helping make STEAM education more accessible to everyone. Now let's get back to the project. In today's project, we will use the ultrasonic sensor to measure distance and display that value on an LCD screen. Here's what you need: Arduino Uno, LCD module, ultrasonic sensor, input-output expansion shield, and a few jumper wires. Start by attaching the input-output expansion shield on top of the Arduino board. This shield makes wiring easier and cleaner, especially for beginners. Next, connect the LCD module to the shield. SCL goes to A5, SGA goes to A4, GND goes to GND, and VCC goes to VCC. After that, connect the ultrasonic sensor. The trigger pin goes to digital pin 9, the echo pin goes to digital pin 10, GND goes to GND, and 5 volts goes to VCC. And that's it for the wiring. If this feels like a lot, don't worry, just follow the wiring diagram that's appearing on your screen right now and you'll be fine. Once everything is connected, go to the GitHub repository of this series, the link is in the description below. Open the folder for lesson 16 and copy the code from the file called measuring distances. Paste the code into your Arduino IDE. But before uploading, make sure you have installed the GFRobot RGB LCD 1602 library. This library is essential for controlling the LCD screen that comes with the Mind Plus kit. Once the library is installed, upload the code to your Arduino. If everything is wired correctly, you should immediately see distance values appearing on the LCD. That is the project working. Now that you've seen the project in action, let's break down the code step by step. We start by defining a few constants and variables. These store things like the pin numbers, timing values, and calculated distance. In the setup function, we initialize the LCD screen so it's ready to display text. We also configure the ultrasonic sensor pins. This is important because the Arduino needs to know which pin sends the signal and which one listens for the echo. The real logic happens inside the loop function. First, we generate a very short pulse on the trigger pin. This pulse tells the ultrasonic sensor to send out a sound wave. Immediately after that, the Arduino waits and monitors the echo pin. If no echo is detected, it means there is no object within the sensor's valid range, and we display no object found on the LCD. If an echo is detected, the Arduino measures how long the echo pin stays high. This time value represents how long the sound wave took to travel to the object and back. Using this time value, we apply a simple mathematical formula to calculate the distance. Now, this is where the detecting zone becomes important. Ultrasonic sensors are not reliable at very short or long distances. That's why we define a valid range, in this case from 5 to 100 centimeters. If the calculated distance falls inside this range, we display it on the LCD. If it's outside the range, we treat it as invalid data and print no object found instead. Establishing a detecting zone is extremely important in real projects. Without it, you might treat noisy or incorrect readings as real measurements, which can lead to bad decisions, especially in robotics and automation systems. And if you want to learn more about Arduino programming in general, I already have a full tutorial about that here on the channel. Don't forget to check it out. Before we finish this lesson, I would like to share a quick announcement. I'm currently preparing a masterclass about building drones using Arduino. This masterclass won't be for complete beginners. You'll cover more advanced topics like flight control, wireless communication, energy management, PCB design, and 3D printing. The goal is to teach you how to build your first drone with Arduino step by step. If you are interested, I've created a waiting list and linked it in the description below. Sign up using the form and you'll be the first to know when the masterclass is available. That's it for today's lesson. Thank you for watching all the way to the end. Today you learned how ultrasonic sensors work and how they can be used to measure distance with Arduino. You also built a complete project that displays distance values on an LCD screen. In the next lesson, we will learn how to measure temperature using the LM35 sensor, and of course, we will build another cool project. Until then, I highly recommend clicking and watching the video appearing on your screen right now. I'm sure it will help you improve your maker skills. See you in the next lesson.